Hello and welcome to week 6. Now that we have finished learning some of the basic design principles of structural engineering, including types of loads and methods of analysis for various structural elements, we can finally start to look at specific structural materials. In the next few weeks, we will be discussing when to use different structural materials in different situations, as well as how to size some basic structural elements using different materials. Hopefully you'll notice that a lot of the knowledge and vocabulary that we learned in previous weeks will come back frequently in this final chapter of our Structures 2 course. And hopefully it will all come together nicely in the end here. So, the materials that we are going to focus on in the last 3 weeks of this course are steel, concrete, wood, and masonry, the 4 most popular structural materials used in buildings. And before we jump into any one specific material, let's first talk about some of the criteria that structural engineers need to consider when selecting a material for a building. So when architects select materials to use for buildings, they think about things like aesthetic, durability, cost, ease of construction, etc. And you'll notice that structural engineers have many of the same concerns when selecting structural materials for core structural elements of the building. Of course, there are many criteria that structural engineers consider when selecting materials, and the relative importance of these criteria will vary from project to project and from engineer to engineer. I've done my best to compile what I would consider to be the most important criteria for all projects, but keep in mind that all guidelines that I will be laying out in the next few weeks of this course are very general guidelines. And there may be other guidelines that other engineers may have, and if you find yourself working on a project with an engineer who makes a decision that doesn't quite align with what I have laid out in this course, you should always take their word over mine. There will certainly be cases that fall outside the scope of this course, and so these guidelines are not meant to replace the work or advice of a structural engineer that you are working with live on a real project. So, that being said, let's jump into the first group of criteria for selecting appropriate structural materials for a project, the building use and function. And the most obvious example here would be the anticipated loads and the spans. So back in week 1 we talked about design loads for buildings, and we talked about how they can vary from project to project. Specifically, live loads were dependent upon the building's occupancy. And so a residential home is going to have a very different design load than, say, a sports arena. Also, in later weeks of the course, we talked about load paths. And we talked about how more indirect load paths require more robust structural systems. So for example, a residential home may only have a 20-foot maximum span to create a 20 by 20 room, whereas a sports arena could have a clear span of 10 times that number or more. And so the material that we choose for the structural systems for these two buildings will of course be very different. Beyond just thinking about the loads and the spans for the structure, we should also think about any special restrictions or requirements for the building to be used and to function properly. So for example, commercial office spaces built in the middle of cities, that real estate obviously comes at a huge premium. And the owner will be looking to maximize the amount of square footage in the building as much as possible. And so the structural system will need to be very light and very thin in order to squeeze in a few extra floors, potentially. A hospital or a science lab, on the other hand, may have very different goals. Rather than trying to maximize square footage and building very thin floors, there will likely be sensitive equipment in these spaces that need some vibration control. And so unlike the commercial office building, the hospital will need to have a much thicker more robust, more massive structural system. Lastly, for this first set of criteria for building use and function, we have the fire resistance of the material. And there are actually chapters in the IBC that will restrict the types of structural materials that we can use for different types of buildings based on their fire resistance performance. And we'll be looking more into those chapters in the final week of this course. For now, let's move on to our other criteria. So up next we have integration with other building systems. And the two key ones here are integration with the mechanical, which I'll write out actually as MEP. So that includes mechanical, electrical, and plumbing. Basically the guts of the building. And so mechanical obviously has ductwork, and the electrical will have conduit, and plumbing has pipes. And all of these things will need to puncture different parts of the building. And often the parts that these systems puncture will be structural elements. And you can see here I've given examples of two plan views where with structural steel we can easily frame around the penetration in the floor slab with some supplemental beams. And similarly, with a concrete slab, we need to pay attention to how we lay out the steel reinforcing in the slab around the penetration. Also, when selecting structural materials, we need to pay attention to the architectural style, especially if the structure is going to be exposed and fully integrated with the aesthetic of the building. Finally, we have construction limitations. So to give you an example, where we are here in Boston has historically been a steel city, whereas a place like Washington, D.C. has historically been a concrete city for the buildings that are built downtown. And so in Boston we have a lot more steel workers. In DC there are a lot more concrete workers. And so steel buildings tend to come out cheaper in Boston, and in DC concrete buildings tend to come out cheaper. And so the structural engineer needs to pay attention to the location where the building is being built and what type of workforce is available in that area. Also, the specific site may have some restrictions for what materials can be used based on how the material is being brought onto the site, where it's being stored, how it's being fabricated, etc. So now that we have all of these basic criteria laid out, we can start to look at our first structural material, which is structural steel. And we'll get into that in the next video.